Woohoo, welcome back. I'm here with Square Bear, and we're going to be talking about integration by parts. Woohoo! We're starting out a new chapter, and this new chapter is all about dealing with integrals that are very hard to calculate using the methods we know before. So these aren't just simple antiderivatives. This is going to be techniques that we can use when we get really stumped. Because of the nature of this chapter, I really encourage you to also read the book. I'm going to cover some of the examples, but the book has other examples. And so definitely, take advantage of all the opportunities to practice and learn about different examples, because there are a lot that can come up in these situations. Woohoo! But Square Bear is here, and Square Bear knows all about difficult situations. Okay, so we're going to start by looking at the product rule. And I'm going to say, I'm going to take the derivative of f times g. And because I personally find this difficult to follow, I have colored f blue, so that you can kind of tell the difference between the f and the g. It breaks up some of the text. So remember that when you take the derivative of a product, f times g, you take the derivative of the first function times the second regular function, and then the first plane function times the derivative of the second function. So they take turns. So it's an interesting situation where we've got one derivative in each of the two terms. Now what I'm going to do, weirdly enough, is take the integral of both sides, which I understand is not necessarily the thing that you would think to do, but it is the thing that someone thought to do. So it's going to get us to an interesting new formula. Basically, I'm going to take the integral of the derivative. Now, this side was a derivative. If I take the antiderivative, that's going to undo this. So you're going to see in the next step down, we take the integral of the derivative of f times g dx, and we should end up with f times g. Kind of woohoo? Kind of woohoo. Over on the right-hand side, I'm going to take the integral of the product rule. So I've got the integral of this whole mess, taking turns doing derivatives, dx. Okay, so in this line, I go ahead and I simplify, because I said, yeah, the integral of the derivative, they cancel each other out. So then I've just got f times g, and then I split these two terms into two separate integrals. Now this is where things get exciting, and I know Square Bear is getting very excited. So if I have the integral of f prime times g and the integral of f times g prime, what I can do is I can take this term and subtract it from both sides. And I'm also going to flip everything around. So I'm going to subtract this here, and I'm also going to subtract it there. Okay? So this right there, I'm going to subtract on both sides. And then we end up with moving this term over. We've got the f times the g there. And then we've got the integral of plane f times g prime dx. And I know you're all looking at this going, of course, that makes perfect sense. But just in case you're not, no, this is not obvious. This is something that folks who didn't have access to televisions come up with to pass the time. But it turns out to be a very useful process. This is called integration by parts. And I know you guys we've had our talks about U and V and how I would not choose U and V. They're too close together. They're too similar, but that is the tradition. So let me show you. If I've got an integral and I've got one function, U, and another function, dv, which is really interesting. And keep in mind, they both have to be in x. So they both have, what? They have to stay up, but they also have to be an x. So there are x's hiding inside here. U dv, then I can pull this out as u times v, which is kind of interesting. It's like I take just the integral of just the dv and get v, and then I end up with a v du. Believe it or not, that's exactly what this says. Here's the u, here's the v, this is u prime, this is v, and here's u v prime. Does that make sense? So there's my dv, there's my du. So it kind of makes sense. And as you're looking at this, I could completely understand if you're saying to yourself, well, of course, this is why don't I have this memorized already? And I understand it is not clear what's happening. But basically what this is going to set up for us is that when we get up against an integral we cannot figure out what to do with, we can kind of use the product rule to take it by pieces. And that's why I invited Square Bear, because Square Bear is all about breaking things into pieces. If you can break up your integral into a u and a dv, then you can pull something out and they get a new integral. And with any luck, the new integral is easier to do. So that's the goal. Okay, so if that's all I'm going to tell you, it would be impossible for you guys to proceed. So let me give you some examples. Not impossible, improbable perhaps. So this is one of the poster children of integration by parts. I've got x times cosine of x dx. Now what's the big deal with this? Well, the big deal with x times cosine of x is that I know the integral of just cosine, and I know the integral of x, but having them together makes it very difficult to integrate. So what I'm going to do is I'm going to say, okay, let's let u equal x. Let's let dv equals cosine of x dx. So let's take a look at this. Here's x. This is the u. And then the rest of the integrand, the rest of the thing in the integral is the dv. Now this is important. When you use integration by parts, you need to break the entire thing up. There can't be anything else left. You can't leave off a 2 or a 5 or an x or anything. You have to use up the entire thing inside the integral, which is known as the integrand. Okay, once you set these two up, then you go ahead, see the big arrow. If u equals x, what's du? Well, if you take the derivative of both sides, you just get dx, 1 dx. Okay, what if dv equals cosine x dx? Now, this is the tricksy part. This is the derivative, and so we've got to go antiderivative to get over here. So on top, we use the derivative. But in the second case, we take the antiderivative. And this is what makes the product rule so useful. And that is that one of these gets shrunken and one of these gets expanded in that derivative antiderivative way. And so hopefully it's going to mix it up so that you can do something interesting. So product rule, remember the product rule, if you have a u times a dv, then first you're going to have the product of just the two antiderivatives, u times v. And then you're going to subtract and you're going to switch places. The u becomes a du, the dv becomes a v. So this is, let's see. You know what? I'm going to write it right here. If we've got u dv inside an integral, we end up with uv minus, and then they switch places, v du. Okay? So there's our u. There's our dv. So this is u times v. And then we subtract the integral of v du. Now, why was this helpful? What did we actually achieve? Well, notice that in taking the derivative of x, we end up with dx. Now, when we went from dv to v, we went from cosine to sine. I mean, that's not a big change. Derivatives-wise, cosine and sine are about the same level. They're just going to go back and forth when you take derivatives or antiderivatives, right? Some pluses or minuses get thrown about, but basically nothing really changes a lot. But the x changed into a 1. And so this integral, the integral of sine, that's just cosine, right? The integral of sine is the opposite of cosine. There was a minus here. And so we end up with x sine x plus cosine of x. What do you guys think? And I am already feeling, I can sense that you guys are like, I don't know about this. So let's write it out. I'm going to write it out in one line. Oh, I see my mistake. Oh, pterodactyl, pterodactyl, pterodactyl. You guys are probably staring at this mistake saying, how could you not have seen this? Yeah, I wrote COX instead of COS. There we go. So we've got x cosine x dx. And what's going to happen? This is going to be my u. This is going to be my dv. My u is going to come down to 1 dx. That's my du. And my dv is going to come up to sine of x, right? And that's going to be my v. And so I'm going to get rid of the x, but I'm going to raise up the cosine back to sine. Okay. So I have to start with u times v. So the top level functions x times sine of x. And then I subtract, and then I make a brand new integral. That's going to be v du. Now, how do you remember all of this? Well, it's just the opposite of this one. So whichever one this one is, u dv, this one should be v du. So it's the reverse. And so I have to take the new thing I've got here, which is going to be sine of x with the dx. Now notice that we are playing with dx's and du's and all the like. So make sure when you take the derivative, even though you're taking the derivative of x, and I know it becomes 1, it becomes 1 dx. So include that little infinitesimal there. Okay, so now what makes this easier to work with? Well, x sine of x is already outside of the integral, so we don't have to worry about it. Now, what is the antiderivative of sine of x? Well, that's just the opposite of cosine, right? And then that's going to be x sine x, and then it's minus the minus, so plus cosine of x. Now, I'm going to write plus c. Some of you may object to that. You may look at this and go, well, what, pardon me. Obviously, Square Bear is objecting to it. Square Bear is like, hello, this is the opposite of c. If you want to write that, that's fine. Or if you want to say plus c1. C is some constant. We don't know what it is. So plus or minus, it's not going to change it a lot. So I'm just going to leave it as plus c. But if it makes you feel better, you could make it plus c1 and have that be the opposite of c. And that's how we solved our integral. So now the question that I erased, how can we check? It's a very good question. I'm sorry, I've got the the tail of this. I'm recording this on my phone, and the charging cable keeps bonking my feet. So how can we check this? Well, if you want to check an integral, what are you going to do? You're going to take the derivative. So I'm going to take the derivative, pardon me, of x sine x plus cosine x plus c sub 1. Okay, so we are going to have to use the product rule. So I'm going to take the derivative of x. That's going to be 1 times sine of x plus x times the derivative of sine of x, which is cosine of x. And then I have to take the derivative of cosine, that's the opposite of sine of x, and the derivative of c is a constant, will just be 0. Or I get sine of x plus x cosine x minus sine of x, which gives me just x cosine of x. And what does that mean? I come back up here and I make sure that's what we were taking the antiderivative of. So then, even though I don't have my Elton John puppet, Square Bear can pretend to sing. I know I'm not supposed to sing in these. It's okay, I can't pick out the puppet. It's the circle of life. Pretend I'm singing, but I'm not. So if you take the derivative of your answer and you get back to the original, you've done it. Woohoo! Okay, that is enough. Each of these problems, as you can tell, is going to take a while. So I'm going to break this up into a few different videos. But let's start with that. I would encourage you to definitely try a couple problems, take a break, kind of let it sort out in your head, try a couple problems, come back, keep watching videos. And I will see you in the next video. But even if you don't start your homework, definitely get something to drink. I've got my hydration right here. Woohoo! And I hope you're having a beautiful day. It is about to rain where I am, and I'm very excited because I am a creature of darkness. Yay, Square Bear and I are creatures of darkness, and we're looking forward to the rain. But wherever you are, go out, look at something green if you can, pet a cat, do some art, dance around. Know that I'm terribly proud of you, and I will see you in the next video. Math on, and woohoo!